Hi everyone. In this video we're going to begin to talk about section 2.1, which is distance and midpoint formulas. Okay, so we're going to learn the formula for calculating the distance between 2 points and another formula about calculating the midpoint between 2 points. So to start off, let's talk about the Pythagorean theorem. Okay, the Pythagorean theorem is a theorem about sort of right triangle type stuff. And it says that for a triangle that looks like this, with the right angle being down here, and I have sides A, B, and C, that those sides have a relation that a squared plus b squared is equal to c squared. Okay? And so what we're going to do with the distance formula is we have 2 points, A and B, and then just forget about the rest of the triangle. We're trying to find the distance between A and B, which is C. Okay, which is a small c. So what we're going to do is sort of form this right triangle between those 2 points. Okay, and then that gives us sort of our distance formula. So it would be advantageous for us to reformulate the a squared plus b squared equals c squared equation into something that only involves c on one side. So we want to solve for c like we did in section 1.1. And so we take the square root of both sides, and then we get this number, or we get this relation here. C is equal to the square root of a squared plus b squared. Now, when you take a square root, you have to also include the plus and minus of that number. Okay? Usually when you take square roots, but in this case we only care about the plus. Okay, I can never have a negative distance between 2 points, so I don't need to worry about the plus and minus. It's always going to be the positive of that number. Okay, so that's just a refresher of the Pythagorean theorem, and it helps us with the distance formula. So let's look at the distance formula. A definition in the book of the distance formula says that if the same units of measurement are used on both the x and y axis, then all distances on the xy plane can be measured using that unit of measurements. Okay, so that's not really important for us. What's important is down here in this theorem. Okay, so we're going to find the distance between 2 points using the distance formula. So here they define P1 and P2, okay, as point 1 and point 2. That's where they're using the P's, as x1, y1, and x2, y2. So if you'll envision connecting to that weird sentence up at the top, we have an xy plane, okay, also called a Cartesian coordinate system. Okay, the xy plane, and I have 2 points here, a point 1 and point 2, and they each have an x and y coordinate to them. Okay, the distance between those points, that distance there, is found using this formula down here. Okay, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And so if you'll remember before, we had, with the Pythagorean theorem in the slide before, we had a triangle that looked like this, and sorry for my terrible drawing here, okay, with C, A, and B, and then I have C is equal to the square root of A squared plus B squared as the sort of modified Pythagorean theorem. Okay, and so how does that relate to this? Well, if you look over here, and maybe I'll make this picture a bit clearer. Okay, this point here is x1, y1. This point here is x2, y2. Okay, so now we have some more space to work. To find, I want to find the distance between these 2 points, which I'll put in blue. So what I'm going to do is I'm going to create a right triangle. So I'm going to bring down this point and bring over this point and create a right triangle from that. Okay, and so then here's my A and here's B, so to speak. And so how do I find those points A and B? Well, this point here is going to have the same, so if I were looking on the x-axis, okay, this point right here is x1. Over here on the x-axis, that is x2. x2, because that upper point up here, this one, has an x-coordinate of x2, and it's on like the same x. It's above the thing vertically, but it has the same x value. So that's x2, and then over here, this is y1, and up here is y2. So the distance of A here is really x2 minus x1. Hence, that's where they get x2 minus x1 up here. Okay? And then B is the distance between y2 and y1. So that's where they get that, y2 minus y1. So really, it's just rewriting this, but in a different way. Okay, so now let's use the distance formula. So I give you 2 points. Find the distance between the following points, -4, 5, and 3, 2. So this is, the distance formula says that the distance D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? This is x1, y1, and this is x2, y2. So all you need to do is substitute those in to get the answer. So x2 is 3. So distance is the square root of x2 is 3 minus x1, -4, all squared, plus y2, which is 2, minus y1, which is 5 squared. Okay, so after we have to do the stuff inside the parentheses first. The square root of 3 minus -4, the 2 negatives become 1 positive, and so that's 7 squared for that first part. The second part is 2 minus 5, so that's -3 squared. Okay, this becomes -3 squared, and -3 squared, and we'll put that down here, -3 squared. Okay. 7 squared is equal to 49, and -3 squared is equal to 9. Okay, the negative goes away when you square it. So I get 49 plus 9, which is equal to 58. So I'm looking for the square root of 58, and that turns out out to be, sorry, let me pull up a calculator first. The square root of 58 is 7.62, rounded to 2 decimal places, 7.62. I don't care a lot about how you round. If I do care, I'll tell you how many decimal points to round. If not, round to 2 as default. Okay, so 7.62 is the answer. And that's in the same units as these were, whatever they are. Okay. So I'll go quickly through explaining a little less formally about this right one. So again, I label x1, y1, x2, y2. Get the square root of 7 minus 5 squared plus 5 minus negative 2 squared. Okay, that comes down to 2 squared plus 7 squared. And that's 4 plus 49. So the distance is the square root of 53, which is 7.28. 7.28. Okay, so it turns out that those are fairly similar distances. But that doesn't really matter. We just care about the distance. Okay, so here's your turn. Use the distance formula to calculate the distance between these 2 points.